Good afternoon and welcome to this Ecochlor Ballast Water Management System press briefing and webinar organised by JLA Media. My name is Hugh O'Mahony and I'll be hosting on behalf of our client Ecochlor this afternoon. We're delighted to have participation from viewers in Europe, Asia and the Americas here today, and I'd like to thank you for that given the time differences. In fact, actually I can tell you that we've got an audience of over 300 here today, which should demonstrate the level of interest in the topics we'll be discussing. This afternoon's session will offer an overview of the latest information on real practical challenges facing ballast water management system users in the industry, and we'll go on to discuss a new and exceptional technology that offers a simple and reliable solution for ship owners, especially those with changing trade routes. Compliance with the Ballast Water Management Convention will also be a theme, of course, but and here in the UK, for example, I see that the Merchant Shipping Control and Management of Ships' Ballast Water and Sediments Regulations 2021, there was a recently an announcement that there'll be a schedule to come into force in the winter of this year. However, the focus here today on this webinar will be the launch of EcoOne, which is the latest groundbreaking filterless ballast water technology from Ecochlor and has been developed to address a real and persistent challenge owners face when they're using high flow rate systems. As well as the technology itself, we'll also be hearing from a leading integration engineering company on the installation process and how that can be simplified, speeded up and delivered at lower cost. So I'll just go through the program here this afternoon briefly. We'll have an introductory session, an introductory presentation on the code and commissioning and the experience and tips to help owners achieve compliance. And then we'll move on. That will be from Marcie Merksamer, Vice President of EnviroManagement, Inc. And then we'll move on to an introduction to EcoOne, the filterless ballast water management system from Ecochlor that we're here to talk about today, from Steve Candito, CEO of Ecochlor. And then we'll dive into the technical issues with a presentation from Andrew Marshall, who's the VP of Business Development at Ecochlor. And then last presentation will be on the engineering approach on installation itself, and that will come from Andreas Zontanos, who's a partner for Argo Navis Marine. So as a matter of fact, as there have been so many signing up today, the press is in a minority, but by some distance actually. With ship owners and a range of interested parties at today's events, I need to just let them know that the press are on the line, so that both groups are aware. After the presentations, we'll be going to a Q&A session. And on the right hand side of your screen, you should see a question box there. And if for any reason you can't see the box, then there's a red arrow there. If you click on that, it should drop down. And then if you click on the questions arrow, then the box will open and hopefully you can type in your questions as we go along. And then we'll come to them at the end. I'll try and put as many of those questions as I can, but obviously with so many on the line, I may not get to them all. And if I don't get to yours, please be assured that we'll forward any onto the relevant panel member, and you'll get an answer one way or the other. So just so you know, when you pose a question, you will be identified. So if there's for any reason you want to remain anonymous, just please sign off your question as anonymous, just in case that's a thing. This session is also being recorded and will be available for download afterwards. And I'll just also draw your attention to another arrow in your box you should see, which is an attachments arrow. And that is, there's a couple of data sheets and brochures on there that you should be able to download. Okay, it's nearly enough from me. I need to just remind speakers, just in case they haven't already done so, to turn off any devices so that there's no pings and bongs, whatever. Okay, so without further delay, I will introduce our first speaker. In fact, what you'll see is a presentation from Marcie Merksamer of EnviroManagement, which has been especially pre-recorded for this event, as unfortunately Marcie hasn't been able to join us today. Marcie is a trained environmental biologist. She's focused on aquatic invasive species and ballast water for 20 years. She assists ship owners with regulatory compliance and guides ballast water treatment technology manufacturers through US and international approvals. And she is Vice President of EnviroManagement, an environmental services and consulting company. And she's also a fellow of the Institute of Marine Engineering. So if we could hand over to the virtual Marcie. Thank you very much.
Greetings, and thank you very much for taking time to watch this presentation. My name is Marcie Merksamer. I am the Vice President of EnviroManagement. I want to thank Ecochlor for the invitation to participate in their webinar and this important day on announcements for their EcoOne technology. I've put together some information on ballast water management system commissioning testing, and my hope is to share some experiences and tips that can help vessel owners achieve compliance. One of the biggest aspects of my job is to just sort out and untie all of the confusion that surrounds the various regulations. It's no wonder that there's confusion. There's sometimes different sources of information, such as flag state, port state, classification societies, and service providers. And even sometimes within those groups, they aren't necessarily even aligned. So there's also a variety of regulatory documents that might need to be consulted. And those regulations, unless you're used to reading regulations on a regular basis, can be quite confusing as to how to actually implement them. The way we view it at EnviroManagement is that a vessel owner's job is to operate vessels. That's your expertise. We can assist, and our expertise is in the regulatory requirements, and we can help sort out all of the confusion that might exist. I'd like to briefly tell you just a little bit more about my company, EnviroManagement. We were founded in 2002 as an environmental services and consulting company, and I personally became involved with ballast water topics 20 years ago. My background is in biology, and I could see the devastation that was being caused by aquatic invasive species. Like many of you in the maritime industry, I simply enjoy the ocean. I like recreating in it, I like fishing, and I wanted it to be available to continue those things during my lifetime as well as into future generations. And so that is why I got involved in the issue of ballast water and aquatic invasive species. Our company provides services to ship owners and operators, as well as treatment system manufacturers. We also do some work for the petroleum industry, but that's outside of this presentation scope today. We provide a vessel sampling services, and we can do this in approximately 120 ports globally. Our webpage is listed there, so you can go to that interactive map and click on the different areas where we provide services. And we provide vessel sampling and compliance monitoring services for both EPA and IMO requirements, and just in general help vessel owners as well as treatment system manufacturers navigate the complex regulatory world that surrounds vessel discharges. Now, it's important to recognize that there are a lot of new service providers that have been coming into this market, and that's really good for ship owners because it facilitates price competition. And that's wonderful. But I just want to point out that price is not the only consideration. So just because a service provider can offer you a quotation or maybe has a nice website, it does not necessarily mean that they have the comprehensive background and knowledge that's necessary to support ship owners fully. So just, again, price is important, but I just encourage vessel owners out there to make sure that you're really looking at the qualifications of the service provider that you'd like to work with. We often do encounter situations where vessel owners come to us and they have a report that they don't understand, or they've been told they've failed a test and now they just need to retest. So again, take a look at those qualifications and make sure it's a good fit for your company. When Ecochlor invited me to participate in this webinar, it was a very quick decision for me to talk about ballast water management system commissioning testing. And that's because it's the area where we currently receive the most questions on a weekly basis. So one of the first things I would like to clarify is that the IMO's ballast water management system commissioning testing, or sometimes referred to as D2 testing, is not the same as US EPA vessel general permit testing. Obviously, the Environmental Protection Agency is a US government agency, and they implement the 2013 vessel general permit. The commissioning testing is an IMO requirement. The EPA's permit has annual monitoring and reporting requirements, whereby a vessel has things to do throughout the year. There are 27 different vessel discharges that are regulated by the EPA's vessel general permit. And this also includes monthly ballast water management system functional monitoring, where just the overall operation and function is monitored and reported to the EPA. The EPA has annual reporting requirements that those of you who just finished them, they were due on February 28th. Now, the IMO's commissioning testing is a one-time biological testing requirement, of course, assuming that the D2 requirements are met on that first time. This is an important test because it was actually put in place to protect ship owners. You've just invested in a ballast water management system and everything that goes with it, all the work that went into that. And this testing is to confirm that the ballast water management system is functioning according to the manufacturer's specifications at installation. We all know that to gain type approval, treatment systems have to go through a rigorous amount of testing on all aspects of their treatment system. However, equally important to its ability to meet the discharge standard is how it is designed, engineered, and installed. And that's what this commissioning testing is intended to do. So it's rather important that this gets done. Now, it's also important to recognize that the way VGP testing is done is quite different than commissioning testing. For instance, for vessel general permit testing, we can take a very small, relatively small, I should say, sample volume that can be collected at any point during a normal ballast water discharge. The commissioning testing, on the other hand, for the D2 standard, requires a much larger sample volume. The newest guidance has a minimum of a 1 cubic meter sample of ballast water discharge. It's more involved sampling. We need plankton nets, and we need to be able to separate out organism size classes, and etc. So very different skill sets are required, very different equipment is required, different water volume sizes are required for ballast water, etc. So those are right away some of the first things that I wanted to clarify. Moving on to how the commissioning testing is implemented, we have to ask, when is it required? The IMO's requirement will enter into force on June 1, 2022. However, the IMO encouraged national administrations to implement this testing as soon as possible. So therefore, we always have to ask, who is requiring it? Some flags are making this a mandatory requirement effective now. Other flags are making this as a recommendation, which is not mandatory at the current time. So it's important, the takeaway here for owners is that it's important to check with the flag administration if the commissioning testing is required. And the list that I've got here, it's also important to note that this is subject to change. We're seeing changes in requirements all the time. So as countries decide that they have an interest and the infrastructure in place to begin implementing this and making it mandatory, we will continue to see changes. So check with your flag. As far as how is the commissioning testing done, the guidance is listed in Circular 70 Revision 1, which was approved at MEPC 75. It's very important, as I mentioned earlier, to make sure that a qualified testing organization is used. They not only need to be knowledgeable in the testing that's required, but also shipboard operations. We also want to make sure that the testing organization is accepted and approved by the flag or class, if the class is acting on behalf of the flag administration. And again, this is really important because the last thing you want to have happen is move forward with your testing only to find out that the test protocols they were implementing or the organization themselves was not accepted by the flag. So it's important to do this in advance. I'd now like to share some experiences and tips that can help owners plan for compliance. Compliance and being successful in it doesn't just happen automatically. We actually have to put in some effort and advanced planning. One of the key pieces is scheduling in advance. So as I mentioned before, first checking with your flag if the commissioning testing is required. 2, confirming that the testing organization you would like to work with is qualified and accepted by your class or flag. And then 3, we have to actually plan for commissioning testing and the location where we're going to do it, because we also now have COVID-19 travel restrictions that are in place. So the scientific team that's needed, the equipment that's needed, takes a little bit more time to have in place. It's not that common for a vessel owner to say, hey, you know, I want to have commissioning testing done tomorrow morning, and that automatically a team would be available. There's, you know, as I mentioned before, there are more service providers coming online, but those that are qualified and approved to do commissioning testing are more limited. So schedule this in advance. The next tip that I would have is to plan it at the proper place and time. So what do I mean by that? So first off, we know that typically speaking, commissioning testing is supposed to happen at the shipyard when the treatment system has been installed. And we would do this after the treatment system manufacturer has completed their commissioning procedures. Class has done its commissioning aspect to check for statutory requirements are met, class rules are met, and the system has been handed over officially to the crew. That's when we would do this. And again, the vessel would be in the shipyard. So that's important to recognize when this is supposed to be done. Now, there are cases where commissioning testing needs to be done at a different location. Maybe there's not enough time in the shipyard period, or maybe the water conditions at the shipyard are not appropriate for proper operation of the treatment system. For example, if it's an electrochlorination treatment system, you need saline water for that to operate properly. If that's not available at the shipyard, then you're going to have to look at a more appropriate place to do this. And we also have to look at the ballasting operations of the vessel. So the vessel has to be able to do the ballasting operation that's needed for this testing to be completed. So those are some aspects when I talk about place and time. It's making sure that vessel stresses, draft restrictions, and all of those things are looked at in advance, and make sure that wherever the location is, whether it's at the yard or it's scheduled for a future port, that those things can facilitate this testing being done. And of course, that the water quality meets the requirements of the treatment system. And last but not least, crew familiarity with the treatment equipment is really critical. The ballast water manufacturer is allowed to be present during the commissioning testing, but the manufacturer is not allowed to facilitate or support the crew in operation of the treatment system. So this is part of the commissioning testing, is to make sure that the training that has been provided to the crew is adequate and that the crew is prepared to begin operating this system on a regular basis. So again, take time to plan for this compliance and make sure that all of these different aspects are scheduled and thought about well in advance. This will help you have a successful commissioning test. In addition to the testing organization that might be selected, as well as the class and flag, there are some additional resources I wanted to point out that are available to owners. One is put together and recently published by the Ship Operations Cooperative Program, or SOCP. This guide was developed in collaboration with the U.S. Maritime Administration and Gloston Associates, and that can be available to you. There's a web link there. And it is a comprehensive guide, and it would include information on commissioning testing, as well as a very broad range of topics that are included in that guide. The Ballast Water Equipment Manufacturers Association, or BEMA, has also put together an industry guidance to support practical implementation of commissioning testing. And similarly, that web link is available for use there. I would encourage owners to take advantage of these free resources that are available and utilize them to support in the planning for commissioning testing and a successful test. I've covered a lot of information in a short period of time, and of course there's always more details than can be shared in a brief webinar presentation. So my contact information is here. If I can provide any clarifications, please feel free to reach out. And once again, I want to thank Ecochlor for the invitation to participate and support them as they roll out their EcoOne technology. And I want to thank all of you for your time and attention. I hope you've gained something useful. Thank you very much.
Well, thank you very much, Marcie. I should mention that that presentation was, well, one of the reasons it was so good is because Marcie is also the Secretary General of the Ballast Water Equipment Manufacturers Association. So thank you for that presentation on compliance. And now we're going to move on to the meat of the matter. And I'm going to introduce Steve Candito of Ecochlor. He is the CEO, and Steve is going to talk about the EcoOne itself. The wait is over for the filterless technology. Just a few words about Steve. He has more than 30 years experience in the maritime industry, providing advisory services including strategic planning, regulatory compliance and crisis management to the maritime and environmental communities. Steve was previously an attorney specializing in maritime litigation and environmental law. He's also served as a marine engineer aboard ExxonMobil USA's domestic tanker fleet. Steve is a graduate of Hofstra University School of Law and the United States Merchant Marine Academy. He is co-founder of Ballast Water Equipment Manufacturers Association, and he currently sits on the board of directors now. I'll introduce Steve, but just before I do, could I remind participants that questions, if you want to put questions, the panel is on the right-hand side. Just enter them there, and we'll take them at the end. But before that, take it away, Steve.
Great, thank you. I appreciate that introduction. And let me start by thanking a number of people that made our EcoOne system possible. It actually starts with our customers, our clients that gave us the feedback that they loved our chlorine dioxide technology, but that if they could see one improvement in the system, it would be to eliminate that filter more for their own operational reasons. And so then it moves over to thanking our employees who worked hard over the last year to get this done, to do all the R&D work and to do the actual regulatory compliance testing. They did a great job during the last year. And as you all know, during the last year was the pandemic. So I also have to thank a number of industry colleagues that helped out as well, where our own employees weren't able to travel and couldn't do certain things. And our own network of people, colleagues, really helped getting this done. And then, of course, finally, I'd like to thank everyone on the line today. We have quite a few media representatives, and a number of clients and potential clients that are very interested in this latest development in the ballast water management system industry. So I'd like to thank you for being here today and listening. Next slide, please. So the wait is almost over. The testing has been completed. We know that we've passed all of the regulatory requirements. It's just a matter of preparing the reports and then submitting it to the various regulatory bodies. But our EcoOne system is a revolutionary, cost-effective, filterless ballast water management system. It has all the benefits of our existing powerful chlorine dioxide technology. And of course, you're going to continue to get the renowned best-in-class reliability and global service that you've come to expect from Ecochlor. It did go through very extensive and robust testing, both for the U.S. Coast Guard compliance and, of course, the latest IMO ballast water management system code compliance. So we're very confident about the ability of the system, certainly from an efficacy perspective and certainly from its ease of use perspective. And yeah, you're going to get that same high performance. The chlorine dioxide technology works very well. Andrew Marshall is going to go into a little bit more detail about how that works and how this all came together. We did not have to increase the chlorine dioxide dosage much, so you still get that same tank coating protection. There's really no problem there. And of course, because it is the chlorine dioxide technology, there's no requirement for neutralization at discharge. Next slide, please. And so I'm going to wrap it up right here just to tell you that the new system is called EcoOne. It's a filterless single-step system using the chlorine dioxide technology. You actually now have three choices with Ecochlor. You have our existing filter system that's going to be very good in sort of all environments. You have the latest system now with the without the filter, and then we're also offering a hybrid option that, again, Andrew will tell you more about that may be useful, particularly if you're operating in fresh water or if you're in situations where you still want to use the filter, maybe to have cleaner ballast tanks or something along those lines. And so with that, I'm going to turn it back over to you. Thank you.
Thank you very much, Steve. Very good presentation, very clear. And the roundup gives me the opportunity to segue into introducing Andrew, who's going to talk a bit more about the technology itself and its benefits. Andrew, I'll just give him a bit of a few words. He is Business Development Vice President at Ecochlor, and he has more than 30 years experience in developing and launching emerging technologies in the maritime industry. Andrew is a seasoned executive and has a proven track record of international business development. He served as owner of Marshall Global Consulting Limited, and he was the CEO of Cold Harbor Marine and the COO of Spectral Fusion Technologies. He attended the University of West of England for law and was the secretary on the board of directors of the then newly formed Ballast Water Equipment Manufacturers Association. So Andrew is an elected fellow of the Institute of Marine Engineering, Science and Technology, and he's going to give us a full presentation of the benefits and technology of EcoOne. Thank you, Andrew.
Thank you, Hugh. And without further ado, let's move to our first slide. So if we could nudge over, please, to the next slide. So the first question that people always ask me when we let people know we were going to do something along the lines of EcoOne was, why filterless? And the short answer is because the customers asked us for it. The simple fact is that some ship owners require a ballast water management system with a reliable high volume pumping rate. That is to say, a system that's not going to be impacted by heavy challenge waters with a lot of silt and sediment, where we know that on occasion filtration units and some other bits of inline technology can suffer as a result of the presence of that sediment, and that can lead to delays during ballasting. So we were asked whether it would be possible to develop a filterless version of our technology, and of course we said we would look at that. The requirement, as far as we were concerned, was that it had to be done properly. There are some concerns expressed by some players within the industry, be that ship owners or equipment suppliers, that filterless operation of current ballast water management systems is not always reliable, or that the efficacy of it, the reliability of the treatment, may be under certain circumstances compromised. And I think that that is a valid fear for ship owners especially to hold. So if I could have the next slide, please. I'll try and explain why those fears are valid and why perhaps they don't apply, or certainly don't apply, to Ecochlor's unique and patented chlorine dioxide based technology. If we look at UV systems, for example, it's perfectly reasonable to assume that a UV system will require a filtration unit. And in fact, every reputable UV system available out there, of which there are a number, will indeed incorporate filtration technology. This is because UV relies on the line of sight, a transmission of light to the organisms. And of course, if you've got a lot of silt or sediment physically blocking that transmission, or a lot of turbidity, then you're not going to get an effective treatment, even if you ramp up the power considerably. So it is understandable why you would need a filter unit on a UV system. But perhaps what's less well known is why you might need a filter unit on an electrochlorination or hypochlorite-based system. If I could have the next slide, please. The reason why you may very well require a filter unit for reliable and efficacious operation on a hypochlorite or electrochlorination-based system as compared to a chlorine dioxide-based system is simply down to physics and chemistry and biology. Essentially, the two different methods of disinfection work in fundamentally different ways. Hypochlorite, the output from an electrolysis-based system, typically reacts with any organic matter in the water. So if you're loading very dirty water, very heavy challenge water, then you need to significantly ramp up the amount of hypochlorite that you're generating to be sure that you will have enough hypochlorite left over after the reaction with the background detritus to kill the living organisms that are coming in the water at the same time. Now, if you compare and contrast that with the Ecochlor chlorine dioxide approach, chlorine dioxide is far more selective about what it reacts with, and primarily only reacts with living organisms. So it almost doesn't matter how dirty, how chewy, how challenging that incoming water is. There is some reaction, and we need to increase the dose a little bit, but by nowhere near as much as would be required if you were loading that same water through a hypochlorite-based system. And if you look at that little table that's on the right-hand side of that slide, you'll see a simple breakdown of that. You'll see that the amount that's typically consumed in reaction to the background organic materials is quite considerable, and leaving a comparatively small amount left over for reaction with the living organism, which in comparison with chlorine dioxide, you can see the data there quite clearly. Now, all right, we know that we have to increase a hypochlorite dose, but the problem with that is that more dose means more electrical power consumption, and an extremely high dose represents a potential danger for tank coatings, which are quite vulnerable in these circumstances. So high levels of hypochlorite in the tanks is a bad thing for the longevity of the tank coatings and thereby the structure of the vessel underneath. If I could have the next slide, please. So with EcoOne, our operating parameters are really very, very in favor, or very favorable for the ship operator. We would have, in our original Ecochlor ballast water treatment system, a target dosage of 4.25 ppm. And yet even here on the EcoOne, our target dosage rate is still only 4.6 ppm, which is, as I think you would agree, is a very small increase overall, and is actually still well below the maximum target dosage that we were allowed for the original Ecochlor system under our original type approval certifications, which are currently in place. There is no water temperature limitation on a chlorine dioxide based system, unlike sometimes with a hypochlorite based system. The only limitation that we've placed on ourselves is that we will only use the EcoOne systems for PSU water greater than 1. So if it's brackish or marine, we will use filterless operation where applicable. For fresh water, it was felt that when the chlorine dioxide naturally dissipates and breaks down, that's why you don't need a neutralization step, it produces some salt at the end of that, and that small increase in dose we felt meant that there was a risk that you'd have some salty discharge into fresh water. And since the whole purpose of these technologies is to protect marine and freshwater ecosystems, then discharging salt into those ecosystems, those freshwater ecosystems, was felt to be inappropriate. So for those operations, or for those operations where a ship owner wants to use the filter, we would operate a hybrid system. That is to say, a system that operates with a filter in freshwater at the lower dose, and a system that can operate without a filter in marine and brackish at the higher dose. You'll also notice there that the power consumption for an EcoOne system is tiny. We can treat up to 16,200 cubic meters per hour. That's rather more than most people require. But even at the biggest cabinet size, your power consumption requirement is typically less than 6 kilowatts. So there is nobody going to have a problem with available power on a retrofit of an EcoOne system. Next slide, please. So here's a typical layout for an EcoOne system, and as you can see, it's very clearly, we have the 2 chemical storage tanks for the precursor chemicals. That hasn't changed at all. Those of you that are familiar with our system will know just how easy and how effective the design and installation of those tanks is, although I'm sure our colleagues from Argo Navis will explain more about that later. There's a simple treatment cabinet to which a bypass line is taken. That's about the size of an IKEA wardrobe. So again, there's no real accommodation problems for that. So we take a bypass line from the main ballast line, put it through the cabinet, mix the 2 chemicals together in a chamber in the cabinet, produce the chlorine dioxide, and send that mix of chlorine dioxide and water back to the main ballast line. And that further underscores just how simple our technology is. There are no TRO sensors, no complex plates or tubes or power supplies or anything like that. It's really super simple. And as we all know, in the marine environment, simple means reliable, and reliable means low cost operation in the real world. Next slide, please. So here we have the hybrid option, and the only real difference there is that we've incorporated a filter, so that allows for freshwater operation. What a lot of our customers we are expecting to do is to basically take a full flow operation in marine and brackish water, and then perhaps a half flow operation for those rare occasions when they may need genuine freshwater operation, so that is PSU less than 1. And so that small compromise enables them to enjoy the benefits of the filterless operation, and also some considerable benefit in lower cost installation. Obviously, not installing filters at all significantly reduces the cost of installation. Only having to install 1 filter for a hybrid system also reduces the cost of installation by quite some amount. Next slide, please. So what are these benefits in total? Well, of course, as I've just mentioned, you've got a lower installation cost, and you've got far lower capex on an EcoOne system. Because you're not managing filters, it's an easier operation for the crew. Incidentally, the system automatically monitors whether it's going to be used in freshwater or marine or brackish water, so it's not even possible for the crew to make a mistake and use it in the wrong mode. It does that automatically and flags up the alarm accordingly. Significantly lower power requirements, and whilst we use very high quality components and very high quality filtration units, they do nevertheless need maintenance over the life of the vessel. So if you delete the filter, you delete that maintenance requirement. And even with hybrid, you've still got lower maintenance requirements there. And the option for hybrid operation gives a vessel owner absolute control over the mode of operation of his ballast water treatment system. And that's important. Vessel owners and operators have to have the power to operate their vessels in the most efficient way, because none of these systems make you any money. What they do, what they have the power to do is ruin your day if they don't work properly or they go wrong. So knowing how you're going to operate your system and having the choice of how you operate your system puts the power for operation right back into the hands of the owner and manager of the vessel. Next slide, please. So where are we with testing? Well, as Steve confirmed earlier on, all of the land-based testing is completed, and we undertook full biological efficacy testing for both marine and brackish and for both IMO and US Coast Guard. We also, as a precaution, because we really do believe in testing things comprehensively, we didn't just do the minimum, we did additional extended hold testings, we did additional low salinity testing. We really put this thing through the ringer to make sure that when it hits our customers' vessels, that you're not going to have a surprise that surprises us as well. So testing has been comprehensive and far-reaching, so all the land-based testing is successfully completed. Next slide, please. And the ship-based testing, we've gone the extra mile there as well. As most of you will know, you only, strictly speaking, need one vessel for ship-based testing. We've used two. We've used an Aframax and a VLCC. So again, real-life operations so that you can have confidence in the outcome. I'm happy to confirm that the third of the IMO test was completed today, this very day. So that just leaves two outstanding US Coast Guard tests that will be done between now and probably the middle end of May. We're a little bit dependent on COVID access to the vessels, but based on our timetable, which we started last September, we have every confidence that we will be completed with the vast part of the US Coast Guard testing, as I said, by the end of May. Next slide, please. So what does that timeline look like? Well, because the IMO testing is now effectively completed, we anticipate that we will have our IMO BWMS code certificate by Q3 of this year, which is in line with our original expectations. Our certificate is an amendment to the existing certificate, so we don't have a problem going all the way back to MEPC and GSAMP and all that. All of that was pre-cleared with the relevant authorities at national and international level before we even started the testing, so that we could give our customers confidence that in the timelines that we were talking to them about. Because we'll finish Coast Guard a little bit later, probably end of May, as I said before, that because Coast Guard takes a little bit longer to work through the process of reporting and final approvals, we're setting that date as being sometime late in Q4 of this year. And then the various class societies as we roll out will be through the beginning of 2022 and the flag administrations attached there too. We do not anticipate any problems because we have been consistently consulting and going the extra mile with the flag administrations, with the class societies, with the testing bodies to make sure that nothing can go wrong for our customers at the last minute. Next slide, please. So that just about concludes my technical and regulatory update for EcoOne. We're very proud to bring this product to the market, and I thank what it looks like to be a very considerable number of customers and interested parties who've tuned in today to learn about this. And I'm looking forward to your questions when they come after the next presentation. Thank you, everybody.
Well, thank you very much, Andrew. Clearly a straightforward and simple solution to a very difficult challenge on ballast water management, and also low cost and easier to operate. So excellent detail there on the system. I can see that the questions are starting to roll in now. Just to draw your attention and invite others to participate. The panel is on your right, and just put in your questions there. I should say that where I mentioned attachments earlier, I meant, according to this, handouts. There's a couple of handouts there that you can download from this presentation, as well as downloading the recording later on. Now, our final presentation today comes from Andreas Zontanos of Argo Navis Marine, who's going to drill down into the engineering approach and look at some of the issues around installation. So we'll get a real feel for the practicalities for ship owners there. Let me just introduce Andreas. He is one of the founders of Argo Navis, and he holds a diploma of the School of Naval Architecture and Marine Engineering and an MSc degree in Precision Engineering Metrology from Cranfield University. Before establishing Argo Navis, he worked with 2 Greek ship management companies as a junior and later senior superintendent engineer. Andreas led on-site new building supervision teams in 2 Greek-owned bulk carrier new building projects in Croatia and China, and he also worked as an independent engineer conducting surveys and supervising conversions and repairs. So without further ado, let me introduce you to Andreas. Thank you.
Good afternoon to everybody from Athens. Thank you for the invitation, Ecochlor. Thank you all attendees for watching this webinar. We are invited to share our first experiences with the EcoOne. We will share our first views on the implementation of this new system. We want to prove the obvious, but that the filters elimination will give us a simpler and cheaper system. We will just try to quantify and show some examples. Next, please. So Argo Navis is perhaps the older engineering partner of Ecochlor. We started working with Ecochlor back in 2012, and we have so far finished approximately 80 retrofit studies, corresponding to approximately 140 installations, all of them, of course, with filters, and half of them supervised by our supervisors. Next, please. So we have already been requested by our clients to examine the installation and the effect on already started or completed studies for retrofits of Ecochlor with filters to tankers. Next, please. So we have 2 tankers, one Suezmax and one VLCC for 2 Greek ship owners, and we would like to approach the engineering and see what we should expect, try to compare the systems with and without filters, and draw final conclusions for your reference. Next slide, please. So we expect, of course, shorter project timelines, both for the engineering preparation and the installation. We definitely look for shorter bills of materials, and as a result, we expect a system, as already Andrew mentioned, with less operational obstacles and less maintenance due to the absence of the filters. You can also imagine that the the piping, since it will be less, we will expect less maintenance or wear and tear of the piping as well. So, engineering challenges. The Ecochlor installation, the Ecochlor system installation, presents two main engineering challenges. One is to select a location to install the treatment unit, which, because requires a separate space, it requires, in most of the cases, a deck house to be installed in the safe area, in the area of the engine casing and the funnel of the ship. The second challenge is, of course, the arrangement of the filters. Therefore, here we have the elimination of the filters, and we obviously expect significantly less design effort. Next, please. We will present now figures, snapshots from the 3D model of the piping, which will be required for a VLCC and a Suezmax, starting with the VLCC. On the left, we have the engine room installation designed, and on the right, we have the same ship, the same model, without the filter. For those who know the system, or for those who not, I'm just mentioning the engine room installation of a tanker requires a filter, which is used for the filtering and treatment of the after-peak tank, and also it filters the water which will be used for the mixing with the chemical. So you see this yellowish line, which is the water required for the generator and for the mixing with the chemicals. So on the right, when we have no filter, you see that we need to arrange piping just for the flow meter and for the injection of the chemical. Next slide, please. Similarly, for the pump room, on the left, we have the filters. We have not included the point cloud of the pump room, and in all the snapshots we indicate, because it will be very difficult for you just from one snapshot to have a full perception of the installation. So we have the filters, huge filters, 3,000 cubic meters per hour capacity of each filter, with the piping, the arrangement of the flow meters. And on the right, we have the same pump room installation with some piping just for the flow meter and the injection port, considerably less. Next slide. A Suezmax, again, we have on the left the engine room installation with the filter. You can see the piping is significant. We need to install the filter, we need foundations, we need also an overboard, because when Ecochlor is used to treat the ballast tanks, this filter filters water, and which is required for the generator to mix with the chemicals. All this arrangement is omitted on the EcoOne, and we have just the pipe required again to arrange the flow meter and the injection for the chemicals, just for the treatment of the after peak. Next slide, please. This is a quantification of the piping required, just the straight piping required per diameter of piping. You can see for example, for the 200 diameter piping from 26 meters, we require 10. So approximately we are talking about a 50% less piping material in this particular arrangement and installation. Next slide, please. Similarly, the pump room installation of the Suezmax. This Suezmax has pumps of 2,500 cubic meters per hour. On the left, we have the installation with the filters, very difficult to arrange, with a lot of access troubles. We had to rearrange even the vent duct of the ventilation duct of the pump room. On the right side, you can see easily a lot easier installation just for the flow meters and the injection of the injection of the chemicals. Next slide, please. We can see again similarly the reduction in piping. It's a little less here. We are talking about 30% less piping material. Next, please. And now an indication for the cabling required. The standard system for the Suezmax approximately required, as per our calculations, 6 kilometers of cables. While in the next slide, you would see that without the filter, we are talking about 3.5 kilometers, so 40% less cabling. So in conclusion, definitely we are talking about a much simpler effort. It's a simpler design required to arrange the system. We definitely have a shorter bill of materials, and we expect a lot of significant reduction in the installation time. And of course, the result of all this is that we have a simpler system with simpler operation and less maintenance. So thank you very much. This is the end of our presentation. I would like to really thank everybody for this opportunity for us.
Thank you very much, Andreas. And some hard numbers there on the benefits, and very good to hear. I think we probably need to go straight on to the Q&A, because we are up against the time constraints and we want to get as many in as we possibly can. I can see you haven't been idle during the presentation, so I'm going to try and get as many as I can as possible, and also perhaps ask more than one panelist at a time. So the first question I'm going to take here is, well, there's the two people have asked similar questions, and they relate to how to upgrade the system so that it can be use the filterless type. How can the existing system be upgraded to the filterless type? And that question comes from Sergey Minakov of SCF Management Services. So I perhaps put that to all three of the panelists, and whichever of you wishes to kick off.
I'll go first. All existing Ecochlor systems can be upgraded to either filterless or hybrid operation. There's a relatively small change to some of the pre-treatment components, and there are a couple of extra instruments that are required for the type approval. One, of course, being the salinometer to measure the salinity to check that the correct mode of operation is being used. And then it's just a question of working out how to do the bypass on the filters, either by, and a bypass may already exist, of course, or if it's always going to be used in a filterless mode, it may be possible simply to remove the filter baskets, retain the filter bodies, and just put the water through the filter body without the basket, without the strainer. And but that would limit you to always having filterless operation at that point. But yes, all existing Ecochlor systems can be upgraded. and we'll be pleased to provide quotes for that. It'll be on a vessel by vessel basis, depending on what we find when we get there in terms of the original installation.
Okay. Perhaps that answers that one, unless Steve or Andreas wanted to add something.
Not
Yeah,
really. On my side, it's very straightforward. What Andrew said, I think the engineering effort for this modifications will be minimum, nothing very important.
Okay. All right. So another question, and this one comes from Konstantinos Mamus, and he says, can you please explain again why someone may require the installation of a hybrid system, and to add the filter option? Why a hybrid system? What's the?
Because EcoOne, the pure no filter operation, is only available to be used in marine and brackish water. That's any water above 1 PSU and above. If you have any vessel operation below 1 PSU, you would need to have the filter installed for that. So that's where the hybrid comes in. You can use it without above, use it with below. But if you're operating vessels that never see fresh water, then you don't need hybrid either.
Okay. All right, so we now have a question which is more to do with the practicalities. This is from Dave Smith, and he's asking, what was the maximum, this is a very technical question, what was the maximum turbidity that the system was exposed to, please, in your testing? I
don't have those numbers in front of me. It'll all be in the report. We can get some data to you, but we used at Golden Bear, we used full augments on the test. So those of you that are familiar with Golden Bear know how that system is set up there, and how you do the testing on that particular vessel. And all of those tests that were appropriate were fully augmented with additional additives, so additional mud and other bits and pieces. I do have somewhere in the files the turbidity levels recorded, but they were significant. And all of the on-ship testing, that's in real-time operations. So that data is being recorded, but I don't have it to my fingertips.
Fair enough. Well, we'll follow up on that one afterwards then. Perhaps some of the numbers that were used, we could just drill down into those. And this is a question from Zayad Al-Askari, and he's asking, he says, thanks for all the informative presentations. And he's asking about the dollars. Do we have an average cost reduction benefit on time and effort, as well as the actual equipment and piping? So a total average cost benefit. I mean, I suppose this is a two-parter really, because it's the manufacture and the installation. So perhaps, Andreas, as you offered some hard numbers there, you could fill in.
I will try to have some guess, actually, because we don't have real experience. We have not reached the point that these quantifications have been costed somehow. I would say that we calculated, we estimated, and we indicate in our short presentation that, for example, engineering, if we need altogether from preliminary study to submission to class, something like 2.5 or 3 months maximum, we should expect approximately 20 days, let's say, less, because the installation of the filters usually takes us, especially in tankers or in confined bulk carriers, takes us a lot of effort to find a way to arrange them, to discuss with the owner, to examine all possible limitations of accessibility, maintenance, etc., etc. So now for the installation, if we take into consideration that as we are talking, most of the installations of, let's say, big tankers last, before commissioning starting, 22 to 25 days. Best case scenario, a lot, sometimes longer because of the capacity and of the shipyards. We would expect again, say 1 week shorter or even more, because the job to be done in the pump rooms, for example, will be much less. Money-wise, I wouldn't easily risk a figure now, because but I believe that from the bills the shipyards, the ships got for the installations, if we are talking about 30 to 40, even more % of piping less, and similar figures for cabling only, I would expect similar decrease of the invoices figures as well. That will be reasonable, I think. So
Okay.
these are the first ideas of this.
From an equipment standpoint, very much depends on the type of vessel and whether you're going full filterless or whether you're going hybrid. But as a general rule, from a CapEx standpoint, not including the installation, as Andreas has just alluded to there, you're probably looking at savings anywhere between 25 and 35%. It may even in some cases be higher than that, maybe a little lower than that, just depending on the vessel and the specific requirements there too. But taken with the savings of installation, those are very significant savings for ship owners. But as Marcie said earlier in her very first presentation, none of this should be about price. Price should not be, being slightly naive here, I suspect, but price should not be the overwhelming determining factor in the selection of a ballast water management system. What should be determining that your selection realistically is it a technology that's fit for purpose and suitable for the operations of your vessel under the operating conditions that you subject it to? Is it going to do the job first time, every time, with high levels of reliability, high levels of customer support from the manufacturer, good dependable service, all those kinds of things? Those should be the primary focuses. And of course, if we can do it a little, lower the cost significantly, as it looks like we can, then that's a benefit to the ship owner as well. But that comes somewhere down the list compared to the first priorities that we've just outlined.
Any thoughts to add there, Steve?
Just to reinforce what Andrew said is, I think some of the owners may be a little complacent right now on that issue of making sure you've got a good quality system, because there really is no enforcement of the regulations currently. We're still in that experience building phase, and that was always contemplated to be 12 to 18 months. And I think with COVID, that's likely to be even longer now. But the owners want to be, this is a system that they're going to have on board their ship for the next 10 or 20 years, and there will be enforcement during that time period. So they want to make sure they make a good decision, not based on price alone, but on getting a system that really works for them.
Okay, thank you. Okay, so there have been a couple, well, we're not taking questions from competitors, obviously, but there's been a couple of questions around the same thing, and so I'll just throw this one into the mix as a press question. And this comes from Richard Halfhide from the Naval Architect, and he's saying, why hasn't there been greater interest from other manufacturers in chlorine dioxide-based technology before? Are there drawbacks that others don't see the benefit? What does anyone wish to comment on that?
We patented it. Nobody else can do it. Sorry.
There we have it.
I'm sure that I'm very confident that knowing, when you look at this technology, it is so simple in operation. It's so simple. And that means it's so reliable. I'm sure there are people that would chew their right arm off to have a chance to develop a chlorine dioxide-based system. But I'm sorry, the founders of the company that was before me, God praise them, they had the foresight to patent the application, and that means that nobody else can do it this way.
Well, that seems perfectly clear. That's fine. And then I suppose a follow-up, but it's along similar lines. This is from Norbolk Shipping. This is from Sasha Cornell, and he's asking, Are there, right, fantastic news about the filterless system. Are there drawbacks to such a system? Are there, I mean, maybe asking the wrong audience here, but are there any drawbacks that you can think of that might be bothersome?
Well, unless you really like spending money on piping and wiring, and if you really like doing that kind of stuff, and finding even more space than you've got available, and trying to find more power than you've got available, and all those other things, then no, I don't see any disadvantages. I mean, we use a slightly higher dose. So, I mean, if I was going to really be pernickety, we use a slightly higher dose, 4.6 ppm instead of 4.25 ppm, which means your chemical usage goes up a teensy weensy bit. But other than that, no, there really is no downside to a filterless operation with the Ecochlor system, for all the reasons that we outlined before. I mean, I suppose the more pertinent question is, why didn't we do it sooner? You know, we are where we are. We've gone about it properly. We've gone about it with real solid research and development behind it, stringent testing, real first-class focus on not only just the words of the regulations, but the spirit of the regulations, what it means to get this done properly for ship owners. Because as Steve says, vessel owners have to run these systems, whether it's ours or whether it's somebody else's, for the next 10, 15, 20, 25 years. So really it's incumbent on us as the manufacturers to make sure that they are first-class systems, properly installed, properly designed and engineered. And we think we've done that. So sorry, I can't think of any other drawbacks.
Okay. There are actually quite a few questions about the dosage and the effect that the system might have on tanks and so on, the chemicals and so forth, but I think perhaps they would be better taken in detail afterwards. As I said before, we will make sure we get answers to your questions, but there is one.
Hugh, I just in case anybody's got any concerns about that.
Yeah.
The original Ecochlor type approval, so fully, against which we did all sorts of tank coating tests with the tank coatings manufacturers and proved zero impact at 5 and 5.2 and 5.3 ppm and above and so on and so forth, and all of that type of approval exists. We're not even approaching those levels. We've gone from 4.25 to 4.6, which means we're well within any tank. You know, if you compare that to some of our colleagues trying to run filterless hypochlorite, where you're hearing 12 ppm, 15 ppm, 20 ppm, you know, I'd be concerned about those kinds of things. I'm not attacking colleagues in other companies. They must do whatever they think is appropriate. But the reality is we're still well under 5, which is proven to be safe for tank coatings. And the only reason we've gone from 4.25 to 4.6 is to take account of the extra biota that we're going to see as a result of not having a 40 micron filter. And so there are no problems with tank coatings, no problems with the slight increase in dose. We've been exhaustive in our testing to secure that.
Okay. All right, well, I've noted that we've gone well over the hour allotted to this now, but there are, I think, as I say, quite a few questions of a detailed nature that remain outstanding, and I'm sorry that I haven't been able to get to those. I'm going to bring the session to a close, if I may. A lively session, in fact. So thank you very much for your participation and for your questions, and you'll be contacted in the days ahead if you didn't get an answer to your detailed question. So it only remains for me to thank our speakers today. So thank you to Marcie, Steve, Andrew and Andreas, and for your participation in this Ecochlor webinar. And hopefully we'll see you again at future webinars from JLA. So thank you very much to everybody, and good afternoon. That's the end of the session.
Thank you.
Thank you.
Thank you very much.